Hello, this is Dr. Mears, and today we are going to be using logarithms to solve equations. And you'll have to pardon the little shadows. This is my little camera. I'm not sure why the shadows are being cast like that, but we will handle it and move on. So let's use logarithms to solve equations. Number one, 2 to the x equals 10. Now logarithms are great because when the x is in the exponent spot, it is going to help it come out of that position. So this is what we're going to do. We're going to take the log of 2 to the x, and what we do to this side of the equal sign, we're also going to do to the other. So you're going to place log on both sides of the equal sign. So the 2 to the x gets a log, and the 10 gets a log as well. Then we're going to use the power rule, and this is what's going to undo the x to the exponent spot. So we're going to bring down the x in front. Log 2 equals log 10. Then what we're going to do is we're going to treat this just like it was going to be. We're going to treat log 2 just like it was the number 2. So since x and log 2 are being multiplied, we can divide it by both sides. Cross that out, and x equals. Now remember, if there's no base here, we take the base as being 10. And in our calculator, this is really nice because what we can do in our calculator, our base is 10 as well. So all we have to do is turn it on, clear out that math, and do log of 10, what we have in the numerator. I close the parentheses, divided by log of 2, exactly what we have here. Remember, that little base 10 likes to hide. Enter. Let's do 3 significant figures. So 1, 2, 3. So it's going to be 3.32. Now this 1 right here, we don't round the 2 up because this 1 right here is 4 and less, or less than 5. So we're just going to keep it as 3.32. And that's it. So let's try another one. Now I'm getting, the difficulty level has now gone from a little bit easy to now a little bit medium, because when you notice we have 1 minus 2x as the exponent. But still, the x is in the exponent spot, and our logs are going to help us to undo that. So let's give everybody a log. So we have log 5 of 1 minus 2x equals log 50. Remember, if you give it to the left side, you also have to give it to the right side of the equal sign. This is still an exponent here. I'm going to put parentheses around it. 1 minus 1 minus 2x. So I'm going to bring this whole entire exponent, 1 minus 2x, down. Multiply it by that log of 5, so the log of 5 just stays. So all I did was I just placed it in front, equals log of 50. Now just like I did here, the 1 minus 2x, this whole thing is being multiplied, so I can bring the log of 5 over, x that out. So now I have 1 minus 2x equals, let's do this out. And it's okay if you do. Some people and some mathematicians really don't like to do their logs in their calculator until the very end. But since you're learning this for the first time, let's get this to be a decimal, because I think you're going to help to see that, oh, it's just a regular equation. I don't want you to be really confused. You know, all of these logs are everywhere. So we can do this. Let's do this in the calculator. So let's do log of 50, close your parentheses, divided by log of 5, close your parentheses. We get 2 point, now let's do 3 significant figures, 1, 2, 3. This 0 just is going to leave that 3, so 2.43. I'm just going to go up here because you know me, I write really big. So we're now at 1 minus 2x equals 2.43. So now we just have an equation. We have a two-step equation. Let's subtract 1 from both sides. That's out. I get negative 2x equals 1.43. Let's divide both sides by negative 2, just like we've been doing. Remember, the negative goes with it because this is multiplication, so we're just dividing. So x equals, let's see, so this was minus 1, 1.43, and then let's divide it by negative 2. and we get negative 0.715. So 3 significant figures goes to this 5. Let's just look to make sure if we don't round it up. This is a 3, so we don't round it up. So our answer is negative 0.715. There we go. So the logs really help to get this out of that exponent spot. This comes in so handy for, like, we can solve any equation, everybody. We can solve any equation because we have this log. So it's great. All right, let's go to a difficulty level just a little bit more, and then we'll go on to a word problem. So I wanted to show you all different types. Now, I want you to notice we have 2 times 3 to the x here equals 5 times, this is a times, this is an x variable, it's multiplication. I could have put a little dot if I wanted, so it is multiplication. And this is how they write it in your math book, so I didn't want you to get confused. I wanted you to see what the Oxford IB math book writes it just like this, where this is a multiplication symbol, and then 2 to the x. Now, you can do this in your graphing calculator if you want. I mean, you can do any of these in your graphing calculator. You could make this y1 and you could make this y2. So in your graphing calculator, you could do this. 2 times 3 to the x, y1, y2 equals 5 times 2 to the x, and you can see where they intersect. And you can find that point. And the x value, that is your answer. You could. That's just another way of doing it. But I am going to, instead of doing the graphing calculator, I am going to show you how to do it using logs. So first, just like we've done in the other two, let's give both sides a log. So log 2 times 3 to the x equals log 5 times 2 to the x. Here's where our rule comes in. Remember that rule where we can have same bases and we're multiplying? This is the condensed version. We can expand this out. We can expand this side out. And we can do that by saying 2 times the log of 2 times 3 to the x really could be log 2 plus, that can change to plus, but you have to give another log to 3 to the x. It's kind of like everybody gets a log. And when they do, this multiplication now turns into addition. Same thing on the other side. This is log 5 plus, it was multiplication, but now we're changing it to addition because we're doing the expanded form, log 2 to the x. Again, some of you might say, graphing calculator might be so much better. And that's okay. It's just another way of getting to the answer. All right, let's go back to this. Now, let's get the x out of the exponent spot, just like we've been doing in the other two. So we're just going to move the x's in front of the logs using that's now it becomes multiplication. So x log 3 equals log 5 plus x log 2. There we go. Okay, now we have some simplifying to do, and we have some moving around to do. You see how these two x's are on different sides of this equal sign? We got to get these two together. You see how these don't have an x? They don't have any x's next to them? We got to get these two together. So we need to move things around. So first, I'm going to move this. I'm going to subtract it. And I'm going to subtract it over here. Oops, x log 2. You can't combine anything, you can just sort of move things. Minus x log 2 equals log 5. So I just did, instead of plus here, it now on the other side of the equal sign, it becomes minus. That's it. I can do the same thing here. Minus log 2, minus log 2. Again, I'm just going to be rewriting things. X log 3 minus x log 2 equals log 5 minus log 2. Okay, so you're at this point, right? You're at this point where you could change this to a decimal. You could, and it could just be whatever x. This is multiplication, everybody. It's kind of like saying like 4x, but this is just going to be some big long decimal. You could change this to a decimal, and you can do this out in your calculator if you wanted. What I'm going to do, because this is, well, I want to teach you with how to use logs, is show you almost a little bit of a shortcut. So here's what I'm going to do. I'm not I'm not going to use my calculator yet to change these into any decimals. What I'm going to do is I'm going to say these both have x's. So what I could do is I can factor out the x. So I can pull out the one of the x's, and I can say this is log 3 minus log 2. And I'm running out of room, so you know that I'm almost done. Okay, this is multiplication, right? So what are you going to tell me to do? How do I get this whole thing over to the other side? And you're right, I can divide it out. Log 3 minus log 2. Oops. Divided by log 3 minus log 2. Out. So now in the calculator, I have a job to do. What job is that? That is to put parentheses around my numerator, put parentheses around my denominator, because we got some inputting to do. So now we are data inputting into our calculator. So let's turn it on. Let's clear that up so we have a nice fresh screen. Parentheses, log 5, end parentheses, minus log 2, end parentheses. But here's the thing. These two match. I need to now match this one, so I have to end my parentheses. So this gets a double because this was here, that started it, that ended it. That started it, that parentheses ended it. Divided by log 3, end by, whoops. I'm sorry, everybody. This is supposed to be parentheses. Parentheses, log 3. There we go. So start your parentheses here. You need these. You need these starting just like I have right here. These starting parentheses. This is very important because you have to keep these together. They're a unit. They go hand in hand. Minus log 2, and my parentheses, and another one because I'm now finished and have to match that one that I started. If you can understand how to work your parentheses in your calculator, any computer science major, you're going to say, yes, you have to know how, if you start with something, you have to know to end with it. It's going to make your life easier. And any type of programming in statistics, even if you do R, you're going to need it. So learn how to use parentheses. Okay, so let's press enter. We get 2.259. Okay, so 3 decimal places would be 2.25. But because this 9 is 5 and greater, what we're going to do is we're going to round this to 2.26. So x equals 2.26 because I'm using 3 significant figures. Okay, that was a big one. Some of you might say, oh, I might want to do this graphing calculator one, so this GDC one, and that's fine, you can. It's gonna give you the decimal answer. It will. However, this for any calculus or any math beyond, logs are going to help you solve when your x is in that exponent spot. All right, let's look at the last one, number 4, which is going to be your real world problem. Here we go, let's read it. The radius r centimeters of a fungus on a tree can be modeled by r of t equals 5 times the quantity 2.4 k times to the k times t, where t is the time in days since the fungus was first observed. So let's put time, days. Let's put radius, centimeters. And this K right here, I'm going to tell you, anytime they give you K, this is going to be a constant. We're probably going to have to find that somewhere. That's probably one of these problems where they're going to ask us to find K. All right, let's see what they want first. Per A, state the radius of the fungus when it was first observed. So first observed, that means that no days have passed. So that means that the time is 0. Anytime they ask you to find the beginning or find the first or when it started, your t is going to be 0. This is a very common problem in IB, and if you can recognize it, it's really simple because all you do is you substitute 0 in for t. K times 0. And we don't even need to know what the K is because 0 times K, you got it, is going to be 0. So it's okay that we don't know K. Okay, so R of 0 equals 2.4 to the 0 power. Remember, we do powers first. 2.4 to the 0 power, you got it, is 1. So r of 0 equals 5. So radius was 5 centimeters. Don't forget to put those units on. Okay. Part B. After 4 days, the radius is 8 centimeters. Find the value of K. So they give us T is 4, correct? T, time, 4 days. Okay. Radius, they give us R of T. R of T equals 8. Now we're going to have to find the value of K. Told you that was coming up. So let's substitute some numbers in. R of T, what are we going to put in? 8 equals, so we take out this whole entire thing, equals 5 times 2.4 K times 4, because remember T is times, time is 4. So now we have a variable in the exponent. We know how to do this. We just learned about logs. So let's say, all right, A equals 5 times 2.4. I'm just going to go 4K here, make our lives a little bit easy. Here's the thing. This 5 right here, let's bring it over. Let's just multiply it out. So I don't want to have to do a double log or anything. So we can just divide by 5. You know what? Let's just start using decimals from the get-go here. So we're doing a real-world problem. Real-world problems are going to always end up in decimals. All right, so 8 divided by 5 is going to be 1.6. All right, so I just divided both sides. So I'm at 1.6 equals 2.4 to the 4K. All I did was I flipped this. I like saying 4K rather than K4. What am I going to do, everybody? You got it. I'm going to give both sides a log. Log of 1.6 equals log of 2.4. Oops, sorry. 4K. I feel like we're talking about the TV, 4K. We're not. We're talking about fungus on a tree. Yay. Okay. So we can now, since we took the logs of both sides, remember we can drop this down in front. That's the beauty of logs. So now we have log of 1.6 equals 4K times log of 2.4. Okay, we got to get the K by itself. It's being multiplied by this log. Let's move this log over. Log of 2.4, log of 2.4. Out. We can do the decimal. Let's do it. Let's see what happens. Or yeah, that's fine. You could keep going. We are going to divide. Ultimately, we have 4K here. That's what's going to bring brought down. So ultimately, we're going to divide this by 4. But let's just see what it looks like. Log of 1.6, close your parentheses, divided by log of 2.4, close your parentheses. So that's 0.53, and we can round that to 7. But really, what are we going to end up doing with that? We're going to end up doing 1.6 divided by log of 2.4, and we're ultimately going to divide that by 4. So on my calculator, you know what I can just push? I can just push this division symbol. Answer divided by. I don't have to worry about rounding or anything. 4, if you push the division, it drops your answer down, the beauty of the calculator. What am I going to get? 0.134. So K equals 0.134 to 3 significant figures. Okay, so K will always be that. That's a constant. So now we know what K is. All right, I bet you they're going to have us substitute something in again, right? All right, let's see what they want. Calculate how long it will take for the radius of the fungus to be 10 centimeters. So centimeters, which one's that one? Is that the R of T or is that the T? Centimeters is the R of T. So I'm going to have to take this whole thing out. And what am I going to put in, everybody? You're right, I'm going to put in 10. So 10 equals 5 times 2.4. We have K. 0.134, but we don't know the time. That's what we want to find. Again, the variable is in the exponent spot. What are we going to do? Let's divide both sides by 5. Get that 5 out of there. 10 divided by 5 is 2. 2.4 to the 1.134t. Perfect. Yes, you got it. You're catching on. Log of 2 equals log of 2.4 to the 0.134t. What do we do now? You're right. Bring this and put this in front. That's the whole point behind logs, is to be able to get this out of the exponent position. So we're going to put it right in front, 0.134t. This is really times log of 2.4. Hopefully you're seeing we're doing the same thing over and over. What's coming next? The division. Get this log of 2.4 out. Get this log of 2.4 out. We can do this absolutely fine because what we get, and you know what, let's just do it. Let's clear this out. So we're going to do log of 2, close your parentheses, divided by log of 2.4, close your parentheses. So that's going to give us 0.79, we can even say 2. 0.792 all the way up here. I just did this side, that's what I did, equals, this is out, 0.134t, divide it out, divide it out. Now we're doing some math, everybody. So our time is, we can just simply press the division symbol. Divided by 0.134, enter. We get 0.59, and you know what, I'm going to round that to 1. 0.591. So how long will it take? Wow, that is not really going to even take that long. Oops, not 0.591. What did I do? I missed the decimal. 5.91. That's much better. 5.91. So about, what do you say? 5.91 days. And I would say, you could say about 6 days if you would like to round it. I'd go 3 decimal places, everybody. So to reach 10 centimeters. Yay. Okay, so this has been using logarithms to solve equations and even equations in real life when you're talking about radius of fungus growing on trees. Hopefully it helped. Thanks.